Anyway, we're talking about order of operations. We're talking about in which order things have to be done. And look, guys, this is like ironclad. What I mean by that is we have to follow this. Why does the order of operations exist in the first place? Why do they exist? Who could tell me? I'm just going to draw a name over here. Trinity's not here. Talus. Why does the order of operations exist in the first place? Totally different answer. If you had some big old equation, eyes up here, come on. Hey, if we had some big old equation to work out, and I just said, hey, just start anywhere. Just start wherever you like and start solving this sucker. We would have so many different answers, all of which, except for maybe one, would be wrong, right? Order of operations states that if we follow this sequence of events, then everything's going to be okay. Now, so it's sort of an ironclad rule, but the order of operations can be manipulated. And I know sixth graders are good at manipulation because you like to manipulate your parents all the time, don't you? Yes. Okay, so here's what we'll see what I'm talking about in a little bit. But one of the things that you're going to have to become aware of is that in math there are certain properties. Okay, properties. There's properties about you. That's what makes you you. Makes you unique. Whether you have blonde hair and blue eyes or dark hair and dark eye, I don't know. It's what makes you. Those are the properties of you. Okay, we're going to be looking at four properties today, and you'll see exactly what I'm talking about. These properties are almost sort of rules. They're almost sort of it's just like it's a description of how these numbers work together. Now, the first one that I'm going to talk about is called the commutative property. If I look at the word commutative, I almost see the word commute. We're just missing an E. Okay. How many of your parents work at home? Do we have any parents that work at home? Okay. Raise your hand if your parents have to go somewhere to work. So, yeah, like me, I have to commute. Okay, go like this, commute. Okay, so I'm traveling from one place to another. That is called a commute. Okay, I'm moving my location. Yes, I'm moving my location from my house to my work. It's not a very long commute for me. It's only about 3 miles. I used to ride my bike all the time, very short commute. I've known some people that their commute is like an hour just one way, so it's a long commute. Commutative property states this, okay? 3 plus 8 is the same thing as 8 plus 3. In other words, if I take 3 plus 8 and move things around, right? Move. Say that word. Okay, say commutative. Say move. Say commutative. Say move. Okay, if I move things around, now this is only true with addition and multiplication. There is no commutative property with division and subtraction. Don't even think there is. Okay? If I switch these around, yeah, I get the same thing because isn't 8 plus 3 11? And 3 plus 8 is 11? 11 is 11. With multiplication, it works the same way. If I have 5 times 4, that's the same thing as what, class?
4 times 5.
4 times 5. If I move things around, it's the same thing. Why would you need to move things around? I'll show you that in a little bit. That comes down to being true to the order of operations, right? But also moving things around so we can start being effective math students. Effective math students do things quickly and they don't waste time on unnecessary stuff. They're efficient with their time. That's called the what? Commutative property. That's when we switch things around. We move things around. The next one that I want to talk about is called the associative property. Say that. The associative property. Do you have people you associate with? I see the word associate. What does that mean? I'm going to associate with you. What does that mean? kind of like your posse, man. That's kind of like your group, your homies. All right, you associate. I mean, hopefully, if you're, if you're any decent type of human being, you associate with a lot of people. You don't just like you're not like some elitist where you're like I'm only going to associate with the football players because they're cool and everybody else isn't. You know, or whatever. I know people like that, but that's not really cool. We want to associate with all kinds of people, but we all probably do have an inner circle, right? I mean, we've got friends, and then we also have very close friends that we trust, that we can actually really talk to. Are you with me? Raise your hand if that describes you. Good. So you have a group of people, a group. Say that. A group like that. A group of people that you associate with. Okay? A group of people that you associate with. Okay? Now, the associative property states this. Okay? If I have 4 plus 5 plus 1, and, parentheses state, if I have parentheses, according to the order of operations, what do I have to do? I have to do what's in the parentheses first. I have to. But if all I'm doing is adding, I can move those parentheses. I could say that 4 plus 5 plus 1 is the same, like 4 plus 5 plus 1, doing this first, is the same thing as 4 plus 5 plus 1, doing 5 plus 1 first. Because what am I going to get either way? 10. Keep trying. Yeah, 10, right. Right? Okay. Multiplication would be something like this. If I had 9 times 2 times 1, and I put parentheses around this, that's going to be the same thing as 9 times 2 times 1, but like this, right? So anytime I'm grouping, right? Anytime I'm grouping something, that is the associative. That is an example of the associative property. If I'm making changes in groups, that only works again with addition and multiplication. Okay, addition and multiplication. Okay, and we're gonna play around with these a lot coming up. All right, the third is called the identity. A lot of talk about identity lately. What is someone's identity? What is it? Dallas? Okay, yeah. If you're a superhero, what? Sometimes superheroes have like a true identity, right? Superman was one of those. Clark Kent. Batman was one of those. Bruce Wayne, was that his name? Bruce Wayne. So superheroes typically have a secret identity. In other words, underneath that costume is still the dude, right? Now, understand this. This is not going to be revolutionary to you at all. But did you know? Are you ready for this? Did you know that 5 plus 0 equals 5? Gasp. And 12 times 1 equals 12? I know. But these are examples of what's called the identity property. In other words, the number, if we don't add anything to it, the number doesn't change. If I have Sydney come up here, which you don't have to, if I have Sydney come up here and I don't add anything to her, is she still Sydney? Yes. But, if I have Sydney come up here and then I have Ashley stand right next to her, do I still have Sydney? I have Sydney and Ashley. You see what I mean? Are you with me? Okay. Sydney times 1 is just Sydney. Sydney times 5 is a basketball team. Do you get my point? All right. Um, so in other words, we do things to numbers so that something might not necessarily change. Okay. Now let's first of all just work with this together. Turn to page 22. All right. And on page 22, you see number 1, which states this: 1 plus 6 plus 7 is the same thing as 1 plus 6 plus 7. All right. There looks very, very similar. The only difference is a grouping, right? So on your whiteboards, write down which of the three properties that we've talked about thus far is this an example of? Is this an example of the commutative, where we're moving something around? Is this an example of a associative, where we are grouping something differently? Or is this a matter of identity, where a number has stayed the same? Write down which of the three properties we're talking about. At the count of three, let me see your boards. 1, 2, 3. Boards up. Come on, we got to be ready. Okay, identity? No. Commutative? Yes. Did I move anything around? Did I move any numbers around? No, none of the numbers were moved around, so therefore it's not commutative. What I did move around were the brackets, the parentheses. So I regrouped things differently. This is an example of associative property. Yeah. All right. How about this one? This one's easy. Everybody should get this one. 1 times 10 equals 10. Excuse me. Some of you are thinking, this is a weird math lesson. Why are we learning this? That's okay. It's going to come in really, really handy. Okay? Identity. In other words, the identity has not changed at all, right? 1 times 10 is 10. 10 stays the same because we multiplied it by 1. If we added nothing to it, then it would still be the identity property. Okay? How about this next one? 3 times 5 is the same thing as 5 times 3. I agree with that. But what property is this an example of? Did I move things around? If so, that's commutative. Did I regroup something differently? If I did, that's associative. If I had a number and the answer to that didn't change at all, then that's called identity. Good. I'm happy to see that everybody is saying commutative, and I agree with you guys 100%. How about number 4? We've got 6 plus 0 equals 6. That example of what? Boards up. Good. Everybody's saying identity. Wonderful job. Let's see how these properties, okay, let's see how these properties can actually work to make us better math students, more effective math students, and more like, geniuses. All right, so let's take a look at this. We've got number 7 says 8 plus 23 plus 2. Now, guys, listen. Here's the deal. Don't solve this yet. Okay? The order of operations states that if I keep this the way it is, what do I have to do first? Raise your hand. There are no parentheses, so that's out of the. And there's no exponents, so we're way down there. Sydney, what do I have to do first? According to the order of operations, I have to add 8 plus 23 because it comes first. Yeah, and that's true. We have to be truthful to the order of operations, right? But we can also manipulate things. When you have nothing but addition over here, we can kind of manipulate stuff. Is there an easier way? Because I don't want to do 8 plus 23. That's going to give me I got to go 23 plus 8. I got to, I'm pretty sure I'm going to run out of fingers to do this kind of a problem. What could I do instead, Ashley? She said, if only I could just switch the 23 and 2, because then I could go 8 plus 2, which would give me what? And you know what? I could add tens all day long. That's easy. What's 9 plus 10? 19. What's 19 plus 10? 29. What's 29 plus 10? 39. You see what I mean? I could do that all day long, and that's easy. Do you think I'm allowed to move these numbers around? Because what property would that be? That would be the commutative property. I could apply the commutative property and switch these around. So now I have 8 plus 2 plus 23. And now I can follow the order of operations. 8 plus 2 is 10, and 10 plus 23 gets me 33. Does that make sense? What I just did? Okay. How about this next one? How about this next one? Um, 2 times 17 times 5. I'm multiplying. I'm doing nothing but multiplying. But according to this expression that I have right here, what do I have to do first? What? I have to do what's in the parentheses. Darn it! Because now I've got to go 17 times 5. Crud, I don't want to do that. Is there an easier way? Which way is it? Okay, very good. There's actually two things that I'm going to need to do, so pay attention to this. Okay, the two stays. I'm going to use. She said you're going to use the commutative property and switch these. Okay, so I use the commutative property. I'm just going to put CP there for that actually is a P. Uh, CP there for commutative property. Yes, but I'm still no better off now, am I? Because I'm still figuring out a number that I don't want to have to figure out. So now what do I apply? What? The associate. Come on. Okay, there we go. We use the associative property. Watch what's going to happen. We switch these. Now I'm going to use the associative property to do these first, and then multiply by 17. Why did I do that? How come, Hector? Because 5 times 2 is 10. And what's 10 times 17? 1,700. Just 170. See how easy that was? I mean, I got 170. Now, what I'm forcing you to do today is to kind of really think about each step, okay? But what I'm hoping is that this becomes more of an automatic thing so that when you come across an expression or an equation in the future, you're able to look at it, develop a strategy on how to solve it, and look like a genius in the meantime, you know? Okay, how about, let's look at this one here. 17. Oh, wait, no. Let's do this one instead. 25 times 11. Crud. 25 times 11 times 4. Mm, 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 mm. Hey, now, 25 times 11 is no short order, man. I'm going to have to bust out a calculator or a piece of paper and start working that out. Or is there another way? What are you talking about, Mason? Is there another way? Talk to me, dude. Well, change the 11 with the 4. Yeah, but here's what I would want to do. You're right. We want to get 100. My first thing that I'm going to do is what? Well, if I move the parentheses, then I've got 11 times 4, and that's not going to be much better. So why don't I do this? Why don't I switch these around? 11 times 25. That's called the commutative property, right? Then I'll use the associative property. So that was commutative. Then I'll use the associative property and do this. And this is what you were saying, right? This is what you were saying. So now I have to do this part first. 25 times 4 gets me 100. And 100 times 11 is going to give me 1,100 or 1,100. So I use the commutative property first to move numbers around. I use the associative property second to regroup those numbers, so I could do that pretty much in my head. Okay? Okay, try this one out. 17 plus 29 plus 3. Okay, here's what I want you to do. Find a partner in your group. One of you explain how to solve this, okay, and which property we're going to use, or properties are you going to use, okay? Ready? Go. Okay, class. Who's going to come up here and preach to us here? Huh? Come on up, Ashley. All right. Ashley has been my first volunteer to come up and solve this. Talk us through this problem. That was easy for me to say. Go ahead.
You could do, instead of having to do 17 plus 29 plus 3, you could just do 17 plus 3, and that's, and then plus 29. So then you have 20, and 20 plus 29 is 49, because when you have a 0 on a number, it's
Good. Okay. And at this step right here, what property was that you just exercised?
um,
If we move things around, what property is that? What? Commutative. Very good. And do we even really need these parentheses? We don't, because it's all addition, and we have to solve it from left to right. Okay, that's important to remember with equations. When you have nothing but addition or nothing but multiplication, you solve it from left to right. Okay, very good. Nice work. Thank you. But you'll remember that at the beginning of our period together, I said that there were four properties that we're going to be dealing with. The next one, mm-mm. The next one that we're going to talk about is called the distributive. What does it mean to distribute something? You guys ever been the dealer on like a poker game or Uno game? What do you do? Shoot, 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 shoot. What are we doing? I'm dealing out my cards, right? I'm dealing them out. I am distributing, say that word, my cards. Oh, you don't have to say my cards. Um, when you're distributing something, you're giving something out. The same thing. If everybody in Uno, I think everybody gets what, 7 cards. Yeah. Yeah. So you're distributing 7 cards to everyone, are you not? Eyes up here. 7 cards to everyone. Now, this distributive property is a multiplication thing, and teachers aren't supposed to have favorites, but of all the properties, distributive is my favorite. It's my favorite. Don't tell. Listen. Shh. Do not tell identity, associative, and commutative property that, because they will not forgive me ever. Okay, they each think that they're my favorite. They're not. Distributive is my favorite because distributive's cool. Distributive property can really make you look a lot smarter than you really are. Just kidding. All right, take a look at this. All right, 2 times 19. The old you would solve it like this. 19 times 2, okay, 9 times 2 is 18. Carry the 1, go over to his neighbor, and 2 times 1 is 2, plus 1 is 38. Okay, there we go, 38. Now, that's good, bravo. I mean, if that's what you did, great, and as you should have as a 6th grader by now. But, you know what? Learning is all about learning new approaches to things. And what we can do is we can use the distributive property to solve this. Now, there's a lot of things that equal 19, but the obvious would be what? 9 and 10. So 10 plus 9 equals what? 19. Now, here's what we do with the distributive. We take this times 2, and we do that to each one of these. 2 times 10 and 2 times 9. Okay, I just distributed times 2. Yes? Now, in my head, I can do this. 2 times 10 is 20, and 2 times 19 is, or 2 times 9 is 18. What do I have? 38. You see? It's a faster, kind of cooler way of multiplying, doing a distributive way. Okay? How about this one? 5 times 31. Okay? What two numbers get me 31? 30 and 1. And now let's distribute the times 5. So I multiply by 5 here, multiply by 5 here. 5 times 30 is 150. 5 times 1 is, what's 150 plus 5? 155. See that? I mean, all of a sudden, guys, You're doing multiplication problems in your head, and you're getting them right. And you're not having to use calculators. You're not having to use scratch paper. And honestly, quite honestly, that's the way effective and efficient math students work, mathematicians work. Okay? Let's practice some more distributive because you know what? Honestly, it's just fun. How about 2 times 22? Now, I know it's 44. Okay, this one is pretty easy, but can we prove it using the distributive? Absolutely. What two numbers make 22?
11 and 11.
No, 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 no. Well, that's 20 and 2. Now, I'm not arguing against 11 and plus 11 either. I mean, that obviously works too, but let's kind of be consistent with what we're doing. We'll apply the distributive property by multiplying 2 by 2. Okay, I get 40 plus 4. I get what?
44.
44. Look at that. Look at that. Start training your brain to think along these lines, and you'll be doing some good stuff, man. People will be like, you're just a brilliant child. And you'd be like, yes, I know. Thank you. All right. Turn to somebody in your group and explain how we could apply the distributive property to solve 13 times 6. Okay, ready? Go.
You go 10 plus 3, and then you go 2 times 6, and 6 times 10 is 60 plus 18, which is 78. I'm bored because it's
Class. Okay, good. Now let's talk about this. Sticks of fate. Who shall we choose? Cole. Where's Cole? Cole, man, what's up, dude? All right, Cole. What do we do here, partner? What are we going to do to 13 first? Huh? Let's break this thing up. What two numbers get us 13? There you go. He says 10 and 3. Now let's distribute. 6 times 10 and 6 times 3. Come on. 6 times 10 is what? 60. Plus 6 times 3 is 18. Can you do this in your head? 60 plus 18? What you get? 78. Look at that, Cole. Look at that. You just did this. You got 78, and you didn't have to do this thing like you used to do since like third grade. 18, 7. Okay. Nothing wrong with this, but you know what? I'm all about new learning, and this is a great way of doing it. Okay. This next problem, granted, to do in your head is not as simple. It still can be done. See if you can do it. I'm kind of curious to see if anybody can do this in their head using the distributive method. We've got, without using your whiteboards, we've got 20 plus 6. Okay? Let's just kind of exercise the gray matter here and see if you can do this one in your head. Sydney, you got a question? Sure. Some of you are some of you are looking kind of like you are talking to yourself. You're like, okay, shoot yourself. So you're either doing that math problem or you're talking to the voices in your head again. You do. All right, Alley Cat, what do we do? Okay, talk to me. What?
go 8 times 20, which is 160, and then that would make it
Yeah, 208. I look at it like this. I know I have 160 and 40 is 200. So 8 more is going to be 208. Okay? Not bad. Not bad. All right.